Hello everyone, welcome to Zaraf Game Dev. We are going to start another lesson, which is the inheritance. So let's see what we need to do for our lesson. Let's create our folder, which is for the lesson 9. And in our lesson 9, we are going to have the examples, projects of it. Let's also create the scene to test our lesson. So it is going to be lesson 9 example. And let's create some of the default scripts needed for this lesson. So the first script to test our lesson is going to be the base animal. Then we have a dog and a cat script, which are inherited from the base animal. And finally, for our first example, we are going to have a animal tester script to test our classes. So that's it for all 4 of the scripts. Now let's go inside Visual Studio and let's see how we are going to test those scripts. So let's create our namespace, which is lesson 9 dot examples, and our base animal, it is going to be the base class for all of our animals. And for our base animal, we are going to have a public string for the animal name and age. And we'll have a public virtual void for the make sound. So it calls animal name, makes the generic animal sound. And also a public void describe, and inside the describe, this is animal name and it is dash years old. So that should be it for the base animal. Now inside our dog and the cat, let's put them in the correct namespace. Lesson 9 examples. And similarly for the dog. So for the dog, instead of inheriting from the mono behavior, it is going to inherit from the base animal. And as it has inherited from the base animal, we can create breed. And for the dog, for now, let's set the default to unknown, or we can set it to golden retriever. And after the breed, we can override public override void, and we, as you can see, we can override the make sound. And instead of calling the base, we are going to debug.log animal name box woof woof. and we'll create a public void chase tail, and this method is just going to debug.log the animal is chasing its tail. Similarly, for the cat, we are going to have different parameters. So here we'll have a fur color. It needs to be inherited from the base animal. And again, we'll override the make sound. And after that, we are going to create a new method, and let's call it bounce. And again, it is just going to be a debug long. And to test this, we are going to go into the animal texture, and we'll just get a reference to both of those scripts, and it is going to fetch those scripts inside the start. So public base animal, and we can get the dog reference, and public base animal, the cat reference. And in the start, we'll check if dog reference is not equal to null, then animal name. Similarly, for the cat reference, if dog reference dot make sound and describe. So these are the default base animal methods, and when we cast it to dog reference dot dog, if dog reference is like the dog reference is here, the variable type is base animal, but we can have both the derived classes and the base classes get the reference type by base animal. But now we are going into the derived class, which is the dog, which we have created. And we are going to check if our dog reference, which is referenced by our base animal class, is a specific derived class, which is a dog. And similarly, we have the cat reference, which is going to test specifically if it is a cat. And everything is directly attached here. So all we are going to need to do is uh, just attach those components to a simple test game object. So let's go inside Unity, and let's create an empty, and call it animal tester. And inside the animal tester, I'm going to attach the cat and the dog script, and also the animal tester script. And we'll attach both of the references here. There was a naming issue, but doesn't matter. We'll attach the dog reference to the dog and the cat reference to the cat. So let's see how it is going to work. So when I hit play, as you'll be able to see, it is going to debug.log all the messages. Whiskers is bouncing, so describe Buddy barks woof woof. This is Buddy, and it is chasing its tail. And similarly, Whiskers meows, and it is 2 years old. Now, what happens when we swap those references? So let's see. Instead of cat, we are going to have it reversed. So what it is going to do is Buddy meows meow meow. This is Buddy, and it is 3 years old. And Whiskers barks woof woof. Okay. It didn't change much cause our base animal was doing both of the things, and it only changed the order. So, but as you can see, the class specific methods, which were for the dog, which was the dog is chasing his tail, and the pounce, which was for the whiskers, they did not work. And here we had the cat and the dog reversed. So the naming has also been reversed. But as you can see, we can access the base class methods and call them directly for different cat and the dog. And that should be for this example. Now let's see how we are going to use it in real gameplay. So how it is going to work. So we are going to have three types of collectibles. So the first one will create it as a base class, which is the base collectible. And then we are going to have two different collectibles, which are the coin and the health collectible. So coin collectible and the health pack collectible. And to test it, we are going to need a player. So on trigger. Okay, it already has the trigger and collect, and it is directly going to collect. We are just going to need a player with a player movement, and we can match those there. So let's go inside Visual Studio and let's see how it is going to work. So first of all, we have our base collectibles. So let's attach a proper namespace, which is lesson9.examples. And what we need this base collectible to do is whenever we collide or it collides with a player, it is going to trigger the collect effect. And the collect effect is going to be different for different types of collectibles. So we'll make it virtual. And whenever a different collectible has its own method, then it is going to trigger that specific method. So let's see what we need to have. So let's create a serialized field. Protected. So the derived class can access it. Collected. Collect effect prefab. So maybe we want to have some specific maybe particle effect or sound. And similarly, the virtual method, public virtual void, collect and debug.log. And we are going to play the collect effect. And inside our play collect effect, we are going to protected virtual void. Protected void, and this is going to be here. So the default collect effect is going to be here, and after that, to trigger this collect, public protected and inside on trigger enter if other dot compare tag player, then we are directly going to collect. So that's a default collectible system. Now we are going to have the coin collectible and the health pack collectible. So how are they going to behave? Let's create the namespace for the lesson 9 examples. And similarly for the health pack, so the base collectible is done. Now inside the coin collectible, instead of inheriting from the mono behavior, it is going to inherit from the base collectible. And similarly, public end coin value, which is going to be 1. Then we'll override the collect effect, which is going to collect from the base. And here maybe we'll update the player's inventory or update the UI. I mean, we can do so many things, but for now, I'm just going to debug.log. The coin is collected. And similarly, for the health pack collectible, we are going to have a similar behavior, and it is going to inherit from the base collectible, and we are going to have for the health amount. And similarly, we'll use a debug.log that we have collected the health. Now, to test it, we are going to need to go inside Unity, and let's create an empty, which is going to be coin, and we need to attach the coin collectible here. So for now, no prefab is there, so let's just set it to 10. And similarly, for the health collectible, I'm going to assign the health pack. Now, to test this in our setup, we are going to need to assign a mesh filter and a mesh renderer and a box collider. And box collider is going to be need to be set to a trigger. And let's set the mesh to be a cube. And for the material, we'll use a random player material. And let's reset its transform, and let's add a lighting effect so we can see it. And for the camera, 0, 10, 0, 90. So we are seeing it. Yeah. So in the X direction, let's position it -2. And we can see both of this here. And for the Y, doesn't matter. The Z, it is going to move around. And that is the coin. Let's change its color to yellow. And for the health, let's change its color to green. Now, similarly, we are going to need to create a player. So instead of having it more complicated, let's remove this and let's position this at 2. And let's rename this to blue. And we are not going to have it as a trigger, but we are going to need it rigid body, which is going to freeze the XYZ rotation, only the rotation XYZ. And now it is moving in the XZ plane, then we are going to freeze the Y position, so it doesn't move anywhere. And we need to tag it as a player so our coin and health can detect it. And inside our player, we'll attach a player movement script. So move speed 5. Let's see. Time dot delta time. It moves in the x and the y direction. It is going to be complicated. Let's try simple player movement, simple player controller, and this one. Okay, I mean it works, and we are never grounded, so I don't need to test around with yeah. So let's not use gravity and let's hit play. Maybe it will work, maybe it will not. And let's hide the animal tester so it doesn't show any other log statements. And let's hit play. So the player is able to be movable and base collectible collected, and we collected the health pack. And similarly, the coin is also collected. So as you saw, using just one simple script and uh, taking like similar behavior for all the collectibles, we can like group all the similar methods. Like here we have the play collect effect. We can also include the play sound effect, or maybe play destroy effect. Currently, it is directly destroying the game object, and all the different implementations. Like we have the coin implementation. We can have multiple other implementations, maybe diamond implementation or any other implementation. And that was for this example. Now let's see an advanced example. So it is going to use a weapon. So each weapon is going to have its own some different parameters, and we will need to test it. So let's see what scripts we are going to need. So first we are going to have base weapon is going to have the shared parameters or the default parameters, which are not going to change for all the different weapon types. And next up, we are going to have those implemented weapons, which is a pistol and a shotgun for now. Then we are going to create a weapon controller, which can test our weapons. Hmm. So that should be it for the weapons. Now, let's start by creating the scripts. So first of all, we are going to have the base weapon. Then we are going to have the pistol weapon. And the shotgun. And finally, a weapon controller. So again, we have a base weapon and two implemented weapons, which are the pistol and the shotgun. And finally, the weapon controller, which is going to just directly call the methods related to the base weapon. Now let's go inside Visual Studio, and we are going to see how it is going to be implemented. So let's close all three of this, and we'll open the base weapon, pistol, shotgun, and the weapon controller. Inside the base weapon, let's put it inside the correct namespace. Similarly, for the pistol weapon, and finally, for the shotgun weapon. Now for the base weapon, let's remove this method first. And where is the base weapon? Let's create a header and we'll call it weapon settings. The base weapon stats, and here we are going to have a public float damage, and by default 10f, public float fire rate 1f, and public game object projectile prefab. And after that, we are also going to have a public transform for the fire point and protected float for the next fire time. And by default, it is going to start at 0f. And inside the fire, we are going to create a protected, so protected public virtual void fire, and inside the fire, what we are going to do is first we are going to check if our timer time is greater than next fire time. Then we'll update the next fire time to be equal to time.time plus fire rate. So fire rate. Not 1 divided by fire rate. Just directly fire rate. And we'll use debug.log base weapon firing. And after that, instantiate the projectile prefab. So to instantiate, let's check if projectile prefab and fire point both are not equal to null. Else, if it is null, then just debug.log. The projectile prefab is not attached. That should be it for the fire. If let's make this shorter. If y is capital and your time is less than next fire time, then return. Next fire time is going to be equal to time.time debug.log we are firing and instantiate. Now this if and else like projectile prefab is not equal to null. Decreased one level of indentation, better. Now let's go inside the pistol weapon. And instead of pistol weapon inheriting from the mono behavior, it is going to inherit from the base weapon. And let's create a header pistol specific stats, and let's create a public int for the rounds for burst, and by default it is going to be 1, and inside the awake we set the damage to be equal to 15f and the fire rate to be equal to 0.75 and public override fire. So inside the fire, I mean, we don't need to do anything as everything is done correctly. What we are going to do is just call a debug.log and base.fire. And similarly, it is going to happen with the shotgun, but we are going to need to fire multiple bullets. So let's create a header, shotgun settings, and public int pallets per shot, which is going to be 8, float spread angle, and let's make it 30f, and inside the away we'll set the damage. Okay. So why did damage didn't show up here? Because the shotgun weapon is inheriting from the mono behavior. It needs to inherit from the base weapon, and the default damage is going to be 8f, and the fire rate is going to be 1.5f. And next, what did happen? Can't even. Okay, so fire did test. So next fire time is fire rate. We are firing the shotgun, and if projectile prefab else equals to null, or this is equals to null, then we are going to debug.log next we are going to fire the shots. So fired order rotation is going to equal to let rotation 0 and z angle quaternion dot Euler. Instantiate projectile prefab. So this should fire the shotgun. Now to test it, we are going to need the weapon controller, and let's put it inside the correct namespace. And here we are going to have a reference to the public base weapon current weapon, and inside the update, if we are pressing the button which is the fire one, or which would be the left mouse button, then it is going to fire, else it is not going to do anything. So that should wait for the weapon controller. And to test it, we are going to so let's hide all three of these, and we are going to first need our weapon. And inside our weapon controller, we are going to need a target, and our weapon control is going to reference the weapon controller, and we can attach both the pistol and the shotgun weapon here. So for now, both of them are using the same fire point, and there is no any projectile prefab, so we'll need to create a bullet. And to test if it is working, let's just create a mesh renderer and mesh filter. So the mesh is going to be a capsule, and the material, let's make it blue. So currently we are viewing from the right. Let's make it 90 degrees, and let's decrease the size to 0.4. So it looks like a bullet, and green, red, blue. Let's just make it blue, and we'll need to attach a rigid body so it falls down. And let's make the gravity scale. Doesn't it have a gravity scale? So it is using gravity. Mass is not going to change. So let's have at the default gravity. And for the target, we are going to assign both of the bullets here. And let's move the bullet a little bit to the right. And our target is also at 0, 0. And let's set our current weapon to a pistol. And let's hit play. Let's see what is going to happen. So when I hit play, the weapon is fired. So it is firing. And similarly, if we use the weapon controller target, I mean, let's also add the shotgun weapon and let's hit play. So we should be able to see a couple of different shotguns. It is moving in the Y direction, but, but, but the camera is aligned completely wrong. Projectile prefab or fire point is not aligned. So let it space and let's see what is going to happen. Okay, shotgun weapon, projectile prefab or fire point is not aligned. So bullet is there, target is also there. Why did it show? Okay, so that was the issue with the equal to. So I messed up uh, the different. And to see if it is working or not, I'm going to need to change the camera angle again. Let's hit play. And okay. Let's the camera -10. Yeah. Now let's hit play. Okay, all the bullets are firing, but they are only having different rotation, not moving in a different speed. Hmm. I mean, I can fix it, but do I need to fix it? It has a rigid body. Shotgun. I can add a random explosion force. So let's go inside the Visual Studio and let's see how we can add some force to it. So var palette and palette dot get component and get the component to rigid body and transform dot forward multiplied by 20f. Rigid body dot speed, angular velocity, point velocity, linear velocity. Let's set the linear velocity. Why is it showing linear velocity? No. Transform dot forward multiplied by 20f. I don't know which one is forward. Now let's see how it is going to behave in Unity. Some of the projects or that has been changed. Okay, I mean linear velocity, rigid body dot velocity is already upgraded. Let the scripts. So now let's see where our bullets are going to get shot. So as you can see, they are spreading in different directions depending on the velocity. And we can only fire after 1.5 seconds. So that was the fire rate. And that was it for this lesson. I mean, examples for this lesson.